Hi guys, in this video I would like to share with you 4 selected questions about matrix inverses with detailed solutions as usual. At the end of the video you can find 3 questions for practice and the answers only are provided. I need a few minutes please to go over some items and basic ideas in matrix inverses. Only one slide, please. So, inverse of a square matrix. So, to find the inverse of a matrix, if it exists, first of all, it should be square matrix. Square matrix means n by n. So, 2 by 2, 3 by 3, 4 by 4, etc. And then we have to know the identity I. See the identity here? So this is the same here. Identity for 2 by 2, 1, 0, 0, 1. Identity for 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1, and so on for 4 by 4, 5 by 5. If we have an inverse for A, then we can multiply A times A inverse, and the answer should be I, identity. Also, A inverse times A is I. We will see this formula here in many questions today. We can see that the product here is commutative. The product of this matrices A times A inverse is equal A inverse times A. But in general, they are not commutative. So in general, if you have any size, A times B not equal to B times A in general. Now we can read this as A inverse. This is not 1 over A, there is no division there. And now one more thing here, I will say singular matrix. We call the matrix singular if it has no inverse and its determinant is 0. We call the matrix non-singular if it has inverse and the determinant is not equal to 0. So the last formula here, if we have a 2 by 2, we will apply it also maybe 2 times today. If we have a matrix A2 by 2, like A, B, C, D, any numbers there, then the inverse directly, there is a formula, 1 over the main diagonal AD minus BC. And then inside here, I switch the main diagonal, so it becomes DA, just switching. And the other diagonal, I leave it, but I'll multiply with minus 1. So it becomes minus B, and here is minus C. One remark here that AD minus BC, this is a number. It can be 7 or minus 2 or 1. This number is the determinant of A. It can be 0 also, AD minus BC. If AD minus BC is 0, then there is no inverse for A. If it is any other number, just multiply it inside like a scalar multiplication. Let's start with question number 1. Use an inverse matrix to solve the linear system. What do we do here? We have to change the whole linear system into matrix equation. X plus 4y is equal to 6. 2x plus 7y is equal to 11. I know we have many ways to do this. Easy ways you can do by elimination, you can use substitution, you can use graphing, you can use Cramer's rule, you can use Gauss elimination method. But we need in this example to use the matrix inverse. Let me show you what do we do. We just take the system here and then I convert the whole system into matrix equation. See what I get here? I just take the coefficient 1, 2. Remember the x values here, the x, they should line up, and the y, they should line up. And then I say 1, 4, 2, 7. So I will call this A. This A matrix is called the coefficient matrix. So this is the coefficient of the matrix equation. xy, I put here xy, and then equals b, b 6, 11. Now multiply by A inverse. See this formula here? A matrix times X is equal to B. If I multiply by A inverse on this side, A inverse on this side, then I will get X equals A inverse B. That's what I need to use. So the whole idea now is to find the inverse of A, then multiply by B. So the inverse of A, I can use the formula here, this formula, the last line here. Okay. You can pause now if you like and find the inverse of A, check yourself, find the inverse of A, then multiply by B. Okay, let's go. So A, 1427, by the inverse formula, it will be 1 over AD, 1 times 7 is 7, 4 times 2 is 8, so 1 over 7 minus 8. Switch the main diagonal, see 7 and 1, and only multiply with minus 4 minus 2. 1 over 7 minus 8, this is a number minus 1. So I multiply back here inside with minus 1. So it becomes minus 7, 4, 2 minus 1. Now this is A inverse, minus 7, 4, 2 minus 1. I multiply by B, B 6, 11. So this one will be the row 1 times column 1. 6 times minus 7 minus 42. 4 times 11 is 44. When you add, you get 2. 6 times 2 is 12. 11 times minus 1 is minus 11. This is X and this is Y. So the solution will be 2, 1. Okay, another question. Given the matrices, here we have a little idea, hidden idea. Given the matrices E, 1, 3, minus 2, 2, and EF is given. See, there's a little twist here. EF is given, so the whole product is covered and given, minus 10, 12, minus 5, 0. And we need to find the matrix F. Okay. Well, you can try it for 1 minute or 2 minutes, please. What can we do? Many ways we can do actually here. E is given, FE is given, we need F. My method here is since I have E already there given, I can find the inverse of E and put here the inverse on the right side and put here the inverse. So I can multiply by the inverse on the right side. Because remember, the product is not commutative. Look at the trick here. E is there, FE is there. I will go slowly. Multiply the second matrix, this one here, the second, from the right side by E inverse. So I put E inverse on the right side. Also, I put E inverse on the right side. I cannot multiply from the left side in this example because the product is not commutative. So if I multiply from the right side, you see that? E inverse, E inverse. Now remember, E times E inverse is I. That's the identity. And then I times the F. See, F times I is already F because I is the identity matrix. It does not affect in the product. So this is F. You see, what I need is F. F will be minus 10, 12, minus 5, 0 times E inverse. So the only thing we have to do in this example, the inverse of E, and then multiply. Also, you can pause a little and find E inverse if you like, and multiply by the given minus 10, 12, minus 5, 0 to get the matrix F. Let's go. So E inverse, I apply the same rule, 1 over determinant, 1 times 2 is 2, minus 3 times minus 2 plus 6. Switch the main diagonal and multiply with minus the other diagonal. I will keep here 2 plus 6 is 8. So I will keep 2 over 8 if you multiply by scalar minus 3 over 8, 2 over 8, 1 over 8. So this one is E inverse. I put it here. See, minus 10, 12, 5, minus 5, 0 is given there. And then E inverse I found. So I just multiply row. I think you know how to multiply. Row by column. You'll get the first number. And then row by column. I will say it again. Row 1, column 1. So minus 10 times 2 over 8 plus 12 times 2 over 8. When you add these numbers, you get half. One more time. Row 1, column 2. Minus 10 times minus 3 over 8 plus 12 times 1 over 8. When you add these numbers, you get 21 over 4. You can do the same down to get F. Let's see question number 3. Question number 3 is, we can say, maybe a little tricky. Simple and tricky. I don't know how, but you can try now. Given the matrix T, 3 by 3 now we have 5, 7, 4, 3 minus 1, 3, 6, 7, 5. If the inverse of T exists, so we know there is an inverse, because sometimes the inverse does not exist if the determinant is 0. But I'm telling you in this question that the inverse of T exists. Find the sum of all entries means the elements, of matrix R. What is matrix R? R is T squared times T inverse. Oh boy, it looks very, very long. What is T squared? You know what is T squared? Well, T squared, you multiply T times T. You cannot square each number. That will be completely wrong. T squared, these are matrices. You multiply T times T. Okay, so you get another matrix 3 by 3. Also, you need to find the inverse, T inverse 3 by 3. It might take maybe 10 minutes or more, because even the numbers are not easy here. So I think this is the best one to pause and try it yourself. What can we do to find R? See, the whole idea now, find R, the matrix R. R is T squared times the inverse of T. Okay, I will tell you now, what do we do? See, it's few lines, 2, 3 lines, I can finish it, but I put it in one slide, I think here. Yeah. We know T squared is T times T. And we know that T times T inverse is I, the identity. So I can split this T squared, T times T inverse. I can take this out. You see, T times T inverse, from there I, T times I is T. So what is R? R is T. Oh my goodness, you see how much easy? So now the matrix R is equal to the matrix T. So there is no need for the inverse. There is no need for the squaring. You multiply T by T. So if you go by the normal method, it might take maybe 15 to 20 minutes. But now you can finish it, I think, 1 minute. So the only thing we have to do, find the sum of all entries. So I found the sum of the first row, see 16 here. Find the sum of the second row, 3 minus 1, 3, that will be 5. Row 3, you find the sum 18. Now you add 16, 5, and 18. Just to make it easy by looking, this is the way I do it. So the answer is 39. Because T is R, so I sum all the elements or the entries of the matrix T. Let's go to question number 4. Also, there is a little trick here. Given the matrices D and the inverse, you see D, it looks easy. 1 minus 1, 2. 2, 0, 6. 3 minus 5, 7. And the inverse is this with fractions. And then I put here some variables. You see MN, See the idea how to find m and n. I think you know the story now. This is not difficult. If you want to try for a minute or so, you can pause and try, please. Or you can directly go to the next slide. So we have D, the matrix 3 by 3. We have the inverse with two numbers are missing. So I need the values of m and n. So what is you can find the inverse for D for sure, but it will be very long. You can find the inverse of D and compare. You will find all these numbers and then you can find mn. But I'll give you a shortcut, easy way to do it. Okay, we know that D times D inverse is I. So I can just write down here what is D, and then I write D inverse. See, if you multiply, the answer is I. We know I identity 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So if you multiply row 1, you see row 1 times column 1. See what do you get here? You can try it. Get a piece of paper, please. You can try 1 times 5, and then minus 1 times 2 over 3, 2 times minus 5 over 3. You add these numbers, you should get 1. Because this location 1, row 1, column 1. But I need mn. So what do? You find appropriate rows and columns. So I can take maybe row 1, column 2. You see this one? Next slide. I take row 1, column 2. So this is row 1, column 2. So this number will be 0 there. You can see it on the next slide. I take row 1 here, row 1 and column 2. So R1 and C2. So 1 times minus half will be here, 1 times minus half. And then I add minus 1 times 1 over 6 there. And then plus 2 times the m there, equal this number. Why this number? This is the entry in the first row, second column. Now simple, easy equation, linear equation. 1 times minus half, take it on the other side. Minus 1 times 1 over 6 minus 1 over 6, take it to the other side. 2m, solve for m will be 1/3. You can try it yourself, so easy. Now we continue to find the n, same way. But now I take row 3, column 3. 3 times minus 1 is there, minus 5 times n is there, 7 times 1 over 3 is there. So this is row 3, column 3. This is the number 1 there. More difficult equation, but this is still linear. Put all the numbers, check it please, and then n will be minus 1/3. Okay, these are the 4 questions. Now we see practice number 1. Try it yourself. Given A, there are x and y, and A inverse, also there are x and y, some numbers. Find the value y minus x. So find x, find y, subtract. Practice number 2, we have a matrix 2 by 2 also, but there are some numbers here, a squared 0 minus a squared a, and the determinant, this is the determinant of y inverse, 27 to the power minus 1. Find the sum of all elements of y inverse. Try it. And also here we have 3 by 3. See, I did example like this. Question number 1, 2 by 2. You can try 3 by 3. Read the question carefully. I gave you here the inverse of the coefficient matrix. Find the solution ABC, multiply A times B times C. Then you will find the answers here. Practice number 1, practice number 2, practice number 3. I would like to thank you for watching and see you in another video, another topic. Thank you very much.